The Nanospec 3000 film analyzer system utilizes non-contact spectroreflectometry to determine the thickness and refractive index of transparent films on substrates. The machine operates by the diode array spectrophotometer generating a corrected spectrum. The resulting spectral data are then compared to a bare silicon reference to determine the exact film thickness corresponding to the interference pattern. There are limitations to the Nanospec. The transparent films must be reflective in the range of 400 to 800 nanometers. The Nanospec can measure features as small as 100 angstroms up to 20 microangstroms with a resolution of 50 angstroms. It can measure down to 100 nanometers in diameter at 40x objective. It can support up to 6-inch wafers. It can measure up to 3 films. It can support up to 200 different recipes or programs. Measurement time is less than 3 seconds. Generally, it is used for silicon wafers. Please speak with a training staff if you need to use another type of wafer. Maximum film thickness is 30 micrometers. Let's now introduce our lab users. There are various parts to the Nanospec film analyzer. The lamp power supply provides power to the microscope's lamp. Never turn off the power supply. Turning off the power supply will decrease the lifespan of the light bulb. The stage is where you load your wafer. It is manually operated. There is also a 4-turret microscope for measuring your sample at different magnifications. The settings on the lens should never be changed. Do not change them. The spectrophotometer head is located on top of the microscope. This black box holds a light bulb. See the MIRC staff if the bulb needs replacing. The eyepiece is used for calibration purposes. Finally, there are 3 filters for the Nanospec. There are orange, yellow, and black filters. The yellow filter is used to allow wavelengths of light from 480 to 900 nanometers to pass through. The orange filter is used to allow wavelengths of light from 580 to 900 nanometers to pass through. And the black filter is used to allow wavelengths of light from 200 to 900 nanometers to pass through. To install a filter, slide it into a slot located near the lamp. If the reference silicon wafer, which is a bare silicon wafer, is not already on the stage, place it on there on the right side of the stage. Then load your sample on the left side of the stage. Make sure that the sample is loaded flat on the stage. Whenever you are loading or unloading a sample, make sure to move the sample away from underneath the objective. This prevents accidentally hitting the sample into the objective. Once you have your sample loaded, begin the Nanospec software by clicking on the icon on the desktop. The program will then start up in the main screen. The main screen will list all the measurement recipes. The Nanospec software supports up to 200 different recipes. We will now select a recipe in order to measure our sample. In our case, we are using oxide on silicon, so we go ahead and select that. Because this is the first time we are using this type of measurement since we logged in, a red window will pop up and ask us if we want to do a reference measurement. Click on yes. Then we are prompted to move the stage to the dark reference position. We can do this by moving the stage all the way to the left or all the way to the right. Once you have the stage in the proper position, click on OK. We now need to focus on the reference silicon wafer using the focusing knob located on the right side of the microscope. We focus by making the edges of the square as sharp as possible. Then click on OK. Now enter in a sample ID. Now we are ready to measure the sample. Move the stage so that the sample is under the objective. Then focus on part of the sample. Then click on measurement. In our case, we have a fit of less than 0.1, which is good for this type of film. We can now repeat this process several times by focusing on different parts of the sample and then pressing the Enter key on the keyboard. If you want to redo any of your measurements, Simply click on it and then press Remeasure. You can show the graph of your data by clicking on the Graph tab. The graph shows reflective light intensity versus wavelength. By going back to the other screen by clicking on the List tab and then clicking on Statistics, we can see our data in a bar graph. We can also change the appearance of our data by clicking on the Style button. We can make the data appear 2D or 3D and to make the bars appear horizontally or vertically. We can see the maximum and minimum by clicking on the Data button. Go back to our previous screen by clicking on OK, then on Exit. We can measure a new sample by clicking on the New Text button. Our screen will clear and we can now perform a measurement on a new sample the same way in which we did before. After this, we go back to the main menu by clicking on Calip. We can save our data on the web by going to Data and then pressing Last Save Measurement Result. It will then show the last saved measurement result. Click on Search. If your data is not already highlighted, select it and then click on Simple Data. Our data will then be listed in a box with a maximum, minimum, average value, and other information. In order to save this, we just go to Process and then Export. We will then get a setup screen with everything selected by default. Then click on Save. Select E. Grover Nanospec in order to be able to view your data on the web. Your data will be saved in a text file. You can now view your data on the web by going to the Data and Information page and clicking on the Nanospec link. Depending on your needs, you might need to edit an existing recipe. This is a common need when working with multiple layers on a silicon substrate. In order to edit a recipe, you need to have administrative privileges. These are given to you once you complete training and are checked out by a trainer. You log on by clicking on Log On from the main screen. After doing so, you will be granted permission to edit or add recipes. Go to Edit menu. Click on Measurement. Here you can edit, copy, and delete recipes. Do not delete any of the recipes. Select a recipe you wish to edit. If there is a button labeled User System, we need to click on it to change it to System User. If it is already labeled System User, we need not do anything. This gives us administrative permissions on the recipe. Once that has been checked, click on Edit. The measurement setup screen will then come up. So now we can select our different layers. The first layer is a substrate and is usually silicon. The Nanospec supports up to 3 film layers on the substrate. We can set the measurement algorithm to be curve-fitting normal. We know that we will use the 40x lens, so we change the lens to the 40x lens. Click on Test. Now click on the 40x lens. Then click on OK. For the first reading, we need to do the referencing by clicking on the reference button. We do this in the same way in which we did earlier in this video. Simply focus in on the dark position by moving the stage. Click OK. Then focus in on the reference wafer. Click OK again. Now we are ready to do our measurement. Click on Measure to perform a measurement. In our case, we notice that the fit is off. We can tell this by the graph and by the high fit value. In order to get a better fit, we need to change our estimated thickness of the film layer. We do this by clicking on Exit, changing the thickness to another value, then clicking on Test to redo our measurement. Select the 40x lens again and then click Measure. There is no need to do the referencing again. We now notice that our fit has decreased and is pretty good. This process should be repeated until you are satisfied with the fit value. If you want to perform multiple measurements, click on Debug, enter in the number of measurements you want to perform, then click on OK. The machine will then perform the measurements. You can stop the measurements at any time by clicking on Abort. There's a Calc button which will bring up the Windows calculator. There are also 2 Save buttons. The first Save button will save only your theoretical reflectance in a file. The second Save button will save both your theoretical and actual reflectance. You can load previous measurements by clicking on Load and then opening up that file. By clicking on the Graph button, you can change your graph to show different things. Once you are done, you can go back to the previous measurement menu screen and save your setup. We will now create a new recipe. As in editing a recipe, you need to have administrative privileges in order to create a new program. Go to Edit, Program, and then Edit again. It is best to just copy an existing recipe, then edit that recipe to your needs. Do this by clicking Copy. Then choose an empty slot, and then click on Execute. Now click on Edit to change the copied recipe. We are now in the Program Editor screen, and we can change the program to our liking. The first thing we want to do is go back to the Edit Measurement Program screen by clicking on Measurement. Change all necessary parameters. One thing you want to do is change the name of the program. Be sure to remember this name because you will need to enter it again later. We also changed other parameters by going to the second page. Now go back to the Edit Measurement Program screen by clicking on Exit. Click Exit one more time to go back to the program editor. Be sure to change the name of that which you used before. Then click on Save. You will notice that we are prompted to enter in a lens. Select the lens from the drop-down menu. Now save the program again. We can go to the second page and change some parameters. For example, we can add the capability to save the measurement results on the web. Just be sure to click the Save button again if you decide to make any changes. After watching this training video, you should have a good understanding of how to load a sample, measure a sample, create your own recipe. If you have any further questions, please see the trainer for this equipment. Please do not direct your questions to Charlie.